teaming, little random fun facts. This last summer I did a triathlon, really like chai tea, and the lost file. I'll let you look that one up.
And I'm Jackie Lasky. I'm also a cybersecurity engineer here at MITRE. So I do a lot of the same things as Sarah, so working on CTI for our attack team, and then also some threat hunting as well. In my spare time, I love to travel. I've been to 20 countries. I love to do drone photography, things like that. And then when I'm home, I love to play with my dog.
Awesome. So today we're going to be talking about what is attack. So if you haven't heard of it, no problem, we'll catch you up. Then we're going to show that mapping to attack can be hard and time consuming. But we hope that we have a solution, which we call TRAM. And we hope that we'll end with how this can help you. So I like to start with David Bianco's Pyramid of Pain. I think it gives a good description as we start to get into attack. I'm sure many of you have seen this many times. But so we'll go ahead and start that things like hash values are easy for adversaries to change, right? They're also easy for defenders to detect. But the problem becomes that if you're a defender looking only for the hash values and your adversary changes one bit in their malware file, well, that hash file value is no longer valid. As we move up the pyramid, same concept for IP addresses, domain names. These are pretty easy for attackers to change. But if we look at the tippy top in the red here, the TTPs, or tactics, techniques, and procedures, these things are at the behavior level. So they're much harder for adversaries to change because, like humans, right, we get stuck in our ways. We have habits that we all have. So this is where attack falls. We hope that we can frame kind of these TTPs with the hopes that they can be detected in your environment. So what is attack? In simple terms, it's a knowledge base of adversary behaviors. I almost like to think of it kind of as an encyclopedia of things that we've seen adversaries do. It's a great place to start there. It's based on real-world observations. Everything that we have in attack links back to an open source report so that you can go read more about that maybe technique or software yourself, as well as just like confirm that we're on the right track, right? It is free, open, and globally accessible. This is important. This kind of falls with MITRE's overall vision of being in the public interest. We hope that students and other organizations can use attack as a common language depending on your purpose. So please feel free to check it out at attack.mitre.org. And it's driven by the community. So as I try to mention, we don't have all the answers. We solely rely on public reporting. And so a big part of that is people like maybe you in the audience who writes reports that we can use for attack. So a lot of the information there is because somebody mentioned, hey, you don't have this technique, or hey, I wrote this report that I think would be added value to the community. So if you're interested in contributing, please reach out. So we'll go ahead and break down the matrix. So this is how it's commonly represented. We have the tactics across the top there, the column headers, and these are the adversary's technical goals. So their goal is to initially access their victim's environment. From there, maybe another goal is to laterally move or collect data from that system. Under each column are the techniques, and this is how the goals are achieved. So for example, if their goal is initial access, the technique and how they might achieve that might be spear phishing. Within each cell, we have even more information. This is the procedures. And here we have specific technique implementation. So as you can see, a couple examples for spear phishing would be that APT-12 sent some PDF attachments, whereas APT-19 was sending like Excel-based documents, right? So an added level of detail there. So this is an example of one of our techniques. For each technique on the website is a description. There's kind of two main parts here. One is just an overall of what the technique is, and the next is how adversaries can manipulate that for their advantage. Because a lot of times adversaries are using normal machine methods, but they're abusing it in some way. Next, we have what platforms this runs on, and a recent update is that we now include a lot of cloud platforms as well. Next, we have data sources for every technique, and these are a high-level starting place, but it's a good place to start if you're trying to detect these techniques. There's some data sources where maybe you would consider looking for logs for a given technique. Additionally, we have mitigations and detection. So kind of like data sources, these are high level because they're going to be very dependent on your own organization and what tools you have in place. But we hope that it's a good start of ways that you can not only mitigate a given technique, but also then detect it after maybe it's been done. As I showed in the matrix, we also have the procedure examples. These are the most granular bit of information for any technique, which maps to what software and/or groups use that technique. We also have references. Again, all of this is open source reporting. We want you to go and check it out yourselves as well. So very similar, we have group pages as well. Again, you'll get a short description of things that we know about that group, as well as associated groups. We realize that these groups are not always a one-for-one because they often come from different data sources and different views of what the group is doing, but they seem to overlap enough that it makes sense to group them together. We have what techniques they used, similar to the technique page, so that you can see exactly how that group uses a given technique. We also include software that a given group has used, and again, references, so please check it out yourself. So how does this information get into ATT&CK? So this is a big part of what Jackie and I do for the ATT&CK team, is we find reliable open source threat reporting. There's many different sources that this comes from, but from there, we then find the behaviors in the report. So thinking back to the attack structure, right? The kind of the why, how, and what the adversary is doing is generally the part of the report that we're looking for. So how does this look? So here I have a blob of text from a report that I'm reading, and I like to initially just kind of read through it, and anytime I really see like a verb, that's normally a good indicator of the adversary doing something, right? If it says like that APT whatever is doing something, I like to just kind of start, highlight that, and I'll map it to attack next, right? Getting started with mapping to attack, sometimes it's easiest to start with the tactic level, right? These are the high-level adversary goals, because it gives you a narrower scope to look for, right? So starting with the tactic, I'm going to go through and map all of these. So starting with that first one, I'll just focus on the first bullet. So the Trojan obfuscates its executable code. As I'm reading that, looking across the different tactics, like I can pretty easily gauge that it's not initial access. That doesn't sound right. They're not collecting anything. And as I move along, when I get to defense evasion, it's like, yeah, okay, it sounds like defense evasion. So from there, I can move on to the technique level. This can be really challenging because there are a lot of techniques. But since we've already found the tactic, we've narrowed the scope of our options, right? You only have to now look in a given column. So as I kind of read that sentence again, obfuscate, okay, it's probably going to be obfuscated files or information. That one's pretty straightforward. But a lot of these can be pretty tricky. So a few tips that I use when mapping to attack is using the search bar on the website for semi-unique words for a given sentence. So like in this example, maybe I would have searched for obfuscate and just see what techniques show up. Also, Control F is super helpful, right? Just being honest. So, so now that we have a list of techniques that we've mapped to attack from this report, what can you do with that information? So we have 4 main use cases. First is detection, and this is probably one of our most common use cases, is people using attack to build out analytics for their environment to search for this type of behavior. As you're kind of doing that, you can build out kind of assessment and engineering plans. You can see where maybe the gaps are in your organization. Like, are you detecting what you said you maybe are? And from there, that can help gauge if you need new tools or new configuration in your environment. Threat intelligence can help you track what APTs or techniques you care about. You can see if groups are evolving over time and adding more techniques to their tool bag. Lastly is adversary emulation. This is a specific type of red teaming where like a red team would use a given adversary, maybe APT 3 or 29, to test that against your environment using those selected techniques.
So attack has a lot of great use cases, but there's clearly a problem. The process for getting our data into the attack site is done completely manually. We often have a huge backlog of unanalyzed reports that we have to kind of prioritize some over others. And also, now that since we have humans analyzing it, we have human error. So this leads to potentially inaccurate information. So two analysts might have two different interpretations of the same text. There's also things like availability bias, which basically means we're more likely to think of the attack techniques that we know or that we've seen before, which could cause us to overlook ones that we're less familiar with. The process for training new team members is also really difficult too. So the process, like you might have seen from Sarah, can get kind of complex. It takes time to learn all the different adversaries that we track, the malware that we have, and the techniques that we have. We're constantly adding more as well and changing things as we go. So that's where our solution, the Threat Report ATT&CK Mapper, we call it TRAM for short, comes in. So this is basically just going to be an easier way to be able to help people map their threat reports to the attack framework. So this is just a glimpse into the process, kind of like how Sarah showed you before, but the process for mapping reports to attack. So we usually start with our backlog list of reports, and we kind of make our way from the high priority reports to the medium priority reports, and then to the low ones. And we either get assigned one or we choose one ourselves. And then after we have the report we want to look at, we kind of go through it like you saw Sarah do, and you highlight along the way, finding the attack techniques that you know or that you don't know, just using Control F, things like that. And then afterwards, you copy and paste whatever you've typed out into the attack site. So it's all pretty manual. And as you can probably imagine, it's a really labor-intensive process. So sometimes it could take anywhere from 2 to 6 hours to go through a report. Like a report might be maybe 1 or 2 pages long, or it might be 30 or 40 pages long, depending on the vendor and the group. So it can be a long time. So life with TRAM, how it works is basically the analyst submits a URL to a publicly available threat report, and then TRAM does some magic behind the scenes, which we'll get into in a few slides, to work through and find these techniques for you. So it's saving you that time of having to go and manually search for these in the report and having to read it really thoroughly as well. So basically what it does is at the end, it'll have a printout for the analysts of the techniques that were found in the report. And you can either decide whether you approve of them or not. So you can go through and either accept or reject, which we'll show you when we do our demo, of how it works. And basically this is helping to make a more streamlined and efficient process for adding data into the attack site. And it'll also help people that are outside of attack because they'll be able to analyze reports and map them without having a diverse, huge knowledge of the attack framework. So before we show you the tool, we kind of wanted to give you like an in-depth, show you an in-depth approach of how we really started this project from start to finish. We always like to preface with the fact that we're two CTI attack analysts. We do have backgrounds in Python development, computer science, but we don't have PhDs in AI or machine learning. So this is definitely there might be problems with our approach, maybe not, but it's definitely a catalyst in the right direction, and we're really excited to share it with the community and see what feedback we get and how we can improve it. So the very first step in our process was to get data. So we do this using the Sticks and Taxis server. So we have sort of an automated automated way of being able to grab the data and use it for our project. So what we focus on is for each attack technique, there's an examples section. So basically we take down these examples and we feed them to our tool. So these are all going to be what we use for our project. We're not using the description or other parts of the attack technique, but just the procedure examples. And since we do this using the Sticks and Taxis server, we always have an automated way of being able to get the most up-to-date version of attack. So whenever there's updates, we can just easily grab that, which is great. So after we've gotten our data, the next step is the pre-processing stage. So this is where we kind of clean up and prepare our data for our tool. So a lot of the text in the world is some unstructured raw text in a human language, and we have to be able to make it understandable by a computer. So basically that's all this step is doing our data normalization. So doing things like removing stop words from text. So words like and or the or it, those all take away and carry a really heavy weight in a sentence. So we just focus on getting rid of that stuff so that our tools can learn from the actual verbs and words that are in the sentences that we want to teach. And then we also get rid of capitalization as well, so getting rid of any extra, less useful parts of the text that we don't need. And then in this step, we also do our natural language processing. So we use Python's natural language toolkit, which is really great. So reducing words to their root, using stemming and lemmatization, and then taking our words and splitting up them, or taking up our sentences and splitting them up into different words so that we can do more analysis with them as well. So after we've cleaned and prepared our data, the next step that we did was to build and train our models. So for this project, we used Python's Logistic Regression, which is a supervised learning classification method. So basically, how it works is you have to feed it data to learn with. You can also use things like TF-IDF and count vectorizer to extract your features. This is all pretty standard out of the box from Python's libraries. And then we also do some tuning of our models with cross-validation. So how it works is each technique has to have their own model built. And for this, we teach each model using their examples section as the positive class. And then the negative class, which is all the false labeled data, is just examples that don't relate to that technique. So for this, we might use things like true negatives, which are sentences that are from a report, but they don't relate to any technique at all. So we can use those to be able to further differentiate between other techniques as well. And then we also use any false positives as well. So if our tool goes through and it says one technique is one thing and then we agree that it's not, we'll feed this back into our negative class to help it learn better. But depending on the feature extraction method that you use, the time may vary to actually build these models out. So we actually use a serialized format in Python called a pickle file. So that way we can easily rebuild these models, or not have to rebuild these models upon every single analysis of our report. So the next step after we've built and trained our models is to test it. But before we could test it, we had to collect a good data set for testing. So our team currently has a Feedly CTI RSS feed that we use to sort of look through and search for new reports that are out in the wild. So Feedly has a really cool feature where you can create a board and sort of save all these reports that you know are going to have good data to them. And then you can use their Python API to bring those down, extract the text in JSON, and feed it to your model. So this worked really well for us because we already knew that these reports were going to have lots of attack techniques in them already. So after we have that, we can start the testing phase. This is kind of where we're just extracting out the sentences from the reports and then feeding it to our model. So basically doing a lot of the same NLP stuff that we did before, but doing it on the new text. And then transforming our test data set with the models that we created from the previous step. So we have to run our sentences the sentences from the reports through each model because a sentence can have more than one attack technique. So basically how it worked before is we gave it training data. So it was learning this sentence equals obfuscated files or information. But this time we're giving it no data at all except for just the unlabeled sentence from a report. And then it makes these predictions on its own. So in this step, we also do a lot of examining our model performance. So looking at things like cross-validation scores for different methods that we're using. And then also doing the average and standard deviation. So things like that. That's all going to happen in this stage. So after the report has gone through the model, we can go through and get a printout of the techniques that were found in the report, which we're going to show you in a little bit. So basically how it works is you go through all the labeled data. There'll be a sentence, and then there'll be a technique next to it if it was found. And you can either accept that technique that was found, or you can reject it. So if you accept it, it'll get tracked as a true positive. Obviously, if you reject it, it'll be a false positive. So this is really useful to be able to go through and a lot quicker go through a report and be able to map it to the attack framework. So after you kind of repeat that process for every technique that was found, you can go through and take care of the rest of the unlabeled data. So this is going to be any techniques that you see that may have gotten missed or something like that. So if you want to add that in, we have an easy way to do that as well. And those will get tracked as a false negative. And then everything else from the report that doesn't have a label or it doesn't have a sentence or technique for it, then that just gets labeled as a true negative. And we can use those to rebuild our negative class for our models again. And the very last step in our process was to create a feedback loop to improve our model. So we used a database to kind of track the different true positives, false negatives, all that good stuff. We had different tables to kind of help keep our annotations all organized so that we could reuse them and make our model better each time. So when you're done with a report, you can export it in PDF, and then if you want to rebuild the model, so if you have a lot of new annotations that you want to add, you can go ahead and create a new pickle file and run that through with your new reports. So there were a lot of challenges along the way that we had. One of the most obvious challenges is that extracting meaning from text is still really hard to do. Humans are time and time again still better at getting meaning from a text than a computer is. And we're just starting to bridge the gap between teaching our classifiers how to learn and interpret meaning from text like a human does. There's also things like prediction error. So this can come from having an imbalanced data set or an incomplete data sample. So having noise in your data or anomalies or outliers. So if we had like an example for a technique that didn't really make sense, it was kind of like an outlier, we had to sort of take that on a case-by-case basis and figure out if that was a really useful way of finding that technique out in the wild. But almost always the problem comes back to not having enough data to train with. So this leads to things like imbalanced data sets where you might have like a really small positive class that you're training with and a really large negative class, which is definitely our case because not every attack technique has a lot of examples. Which also brings me to my next point, was that some techniques have no examples at all. So if they're a new technique, we might have 0 or we might have 1 or 2 examples in our data set. So for that, we can't really build a model with, so we had to have some sort of a backup plan for those techniques. So for that, we use just regular expressions and string matching to find that technique until we have enough data to train with in the future. Cool.
Great. So that was a pretty in-depth view of like what's happening under the hood, but now we want to show it to you. So everything is run locally on the user system. And so once you load it on up, give it just a second. Yep. All right, so let's say I'm on the internet looking around, find this Fin7 report. I'm like, okay, this seems interesting. I think there's probably gonna be some techniques in here. I can go ahead and copy the URL, go into TRAM, hit enter new report, and just paste that in there. I'm also gonna grab the title so that as I have lots of reports, I know where this came from. And then I'll go ahead and submit. So you can see kind of up in the tab, a little circle running. It's doing all the NLP stuff that Jackie just described in the background. So this is a report I actually did manually many months ago while, like shortly after it came out. So I just wanted to go through, and since I already did it, right, let's see if TRAM can find some of the techniques I found. So I see some spear phishing, some scripting, file deletion, scheduled tasks. So this just gives us a preview of what I'm hoping TRAM will find when it's done analyzing the report. See some obfuscated files and PowerShell. Cool, so I think that's it. So go back to TRAM and it looks like it's done. So from here, now it's created this new card with the title, and I can, if I hit view source, it'll just take me back to the original URL. But we're here to analyze. So as you can see, it puts it kind of into this format. I'm going to zoom in and start scrolling. All right, I see a highlight. Cool. So it found something. All right, so now it's giving me 2 techniques, spear phishing link and attachment. So now I can go back, reading the sentence again. It's talking about malicious attachments. So I rejected the spear phishing link and go ahead and accept attachment. Now you can see that it's down in the confirmed techniques. Only accepted techniques will go down here. Like Jackie mentioned, this is important in differentiating when techniques are right or wrong so that we can give the model that information so that hopefully next time we run this report, it won't tag that as spear phishing link. But, and like, that's like a very similar example for the computer to differentiate. So we're working on getting more data in there so it can make those distinctions. But it's a start. So I'll go ahead and look for other techniques in this report. Oh, that's fun. We'll just come up here. Demos are fun. All right. Cool. All right, so I'll go through just a few examples here and there, but essentially at this point the analyst, it is still a manual process to go in and accept or reject the techniques, but we hope it's a much better starting place, right? That the model has at least given you some places that you can start and go confirm if these are right or wrong yourself. And over time, we're hoping that there will be many more rights than wrongs. So just accept a handful here. But so this is an example of deobfuscate, but to show you what happens if I reject it, you can see that it actually removed the highlighting from the report to kind of just remove that visual indicator that there's no technique there. If I had accidentally done that, and I'm like, oh no, I need to add it back, we do have the Add Missing Technique button where users can go ahead and add in additional techniques that maybe the model didn't catch at all, or human error if you need to add it back in, no problem. So once I go through the rest of the report, do another example of the reject just to show that that highlighting is removed. All right, great. So once I would have done that more thoroughly as an actual analyst, right? But we'll go ahead and export the PDF. So give that a second. We'll open it up. So right now, the report itself is just the raw sentences. There's no visual indicator in the body of the report. But my favorite feature is if we scroll down, we get a table that will have the techniques and what sentences those techniques came from. And this will be based on the confirmed techniques in the future. But so as we can see, right, spear phishing attachment, there's that sentence where it was the malicious attachment. Schedule tasks, same thing. I can then go and look at that sentence and see that there was 2 daily scheduled task entries there. All right, so that is it for the demo. So we realized, so this is a work in progress, right? Like Jackie mentioned, we don't have a lot of experience with WebDev or NLP and all of that, so we're really happy with the progress we've made, but there's definitely a lot of work that needs to be done. So we're working on cleaning up the code. There's definitely some little bugs in there. We're hoping to make it more user-friendly. We realize that the report right now, due to the way the NLP tokenization happens, it strips out all the HTML and formatting stuff, right, to clean the data. But we hope in the future to maintain how the original report looked, have more of that format, like the paragraph formatting, headers, images, that kind of thing. And as I showed you with those accept reject buttons, the more times we do that, we're hoping to increase the accuracy of our models. So that'll be an ongoing process. And we're thinking about things in the future too, maybe pulling in multiple reports at once. Maybe we can feed it an RSS feed or give it a directory of reports that maybe you have locally on your system. So maybe you're sitting there and you're like, all right, that's cool, but why does this matter to me? Well, we hope that this makes it easier to get started with ATT&CK. Our team has had several organizations and teams ask, hey, do you guys have training to teach our analysts how to map to ATT&CK? And although we don't have a formal training, we're hoping that maybe a tool like this will make it easier to get started if this seems like an overwhelming task. Additionally, we hope that it finds techniques that we forget about, or like me, haven't really even heard of. We recently added a bunch of new techniques, and I'm not sure that I could tell you what they are, but good thing computers, that's not a problem. So we hope that it will catch the ones that we forget about. Lastly, we hope that you can use reporting that's important to you. So maybe you're in the finance industry, and so you don't care as much about healthcare reporting or whatever it may be. You can focus on reports that are important to you in your organization to get more TTPs related to you. Just kind of a refresh of some things that you can do with ATT&CK. These go back to those 4 main use cases of detections, writing out analytics, making security assessments, and like for engineering decisions, do red team exercises based on maybe the techniques that reports that you found interesting had in them, and so on. So some takeaways. So we hope that today you understand kind of what the adversary's TTPs are, and that attack can help frame these behaviors. You can then use this information in a variety of ways. I think we touched that mapping data to attack is hard and time consuming, but we hope that TRAM makes that easier. And best of all, we do plan to open source this. We're aiming for the end of the year so that the community can not only use it, hopefully help us make it better, and help the rest of the community as well. So with that, I think we have plenty of time for questions, but thank you. That is it. And we do have stickers as well, so yeah. But I saw a hand over there.
Yeah, I had a question, so thank you for this. I've been looking forward to this episode the rest of the Are you also considering a review option or something? Because now you are doing the acceptance and the rejection, but then still you have an inherent bias, maybe?
Yep.
That will be very useful, I guess.
Yeah.
And maybe also think of OCR extraction.
Yeah, we were looking at that. We haven't made like a PDF extractor or anything yet. Like we've only looked at just text, but doing OCR for getting images out of reports or PDFs would be great too. So.
Yep. No, those are definitely on our to-do list. Yeah. Yep. Like you mentioned with the bias, one thing that we were thinking is tracking which analyst accepted or denied different techniques, so that then maybe the rest of the team could review that and give their own input. But that's on the long to-do list that we have. So, yeah. Yes. That is not something we've thought about, but that's a great suggestion. So yeah, something to think about. You.
We don't have the exact rate because every technique is going to have a different model. So they all have their own logistic regression model. So we're using different things like the built-in scoring with logistic regression and cross-validation scores, kind of like tuning things along the way. There's obviously some techniques that have a lot more false positives than others, but those are the ones we kind of work with on a case-by-case basis to try to tune and change things up, like the different folds that we're using and the threshold, things like that. So
go right here first.
So, a couple of questions. One is that have you done a validation of reports themselves? You're basing your assessment on the open source reports, but do you know if people who wrote the report actually
No, currently, I guess we rely a lot on the vendors to provide accurate data, but I would say I'd point back to the references and maybe ask them that, right? But we do take their word for it at this point.
yeah, we have a few vendors that we trust over others, maybe more so, but which obviously has some bias too, but yeah.
Second is probably a suggestion rather than a question, is that based on the report, I think that the report is based on an incident, right? So a couple of incidents, and what your model can't produce is sort of like unique thinking, almost like a signature or a hash of that specific attack.
Yeah.
And maybe you could potentially see whether that particular signature is almost like a maybe an antivirus signature, and you can recognize, all right, that attack happened here, and you could see that these techniques were used, the same techniques were used in a different incident. So you have
Like chaining together, that's, yeah.
claim for retribution, or you can claim that there's a chance, right? So there's not confidence, but there's a higher confidence if you have the same techniques, the same
Adversary.
IOCs, right? Similar attack.
Sure.
Yeah, that's a really good
So just for the folks in the back, the suggestion was having a way to make some sort of signature on a given report with those techniques so that they could be tracked over time. So,
Yeah, that's a good idea.
yes.
So for your technique that have higher false positive rate, does your team or the attack team consider that maybe the technique is poorly designed?
That's a good point.
Like
some
yes,
of
but
them- yeah.
no. So we currently aren't using the description of the techniques for the models, but we are using how that technique is described in a sentence. So I would say that based on that, I don't know that reviewing how the techniques are written would play a huge part into our model for this use case. Yes?
How would you prevent same report being analyzed by different analysts or reading different reports about the same case? I can assume that that's not very efficient if you do so.
Yeah, I mean, we have different unique identifiers for reports that are released. So we'll use that kind of to, I guess, differentiate between ones that have been analyzed and ones that haven't. But if there's another report that talks about the same adversary doing the same thing, we can still use that data because it's described in a different way. So for us, that's good because then we can add it back to our models and have more data to work with. So just having a unique report is fine, but we always want more data. So
Yeah, and just to add on to that, something that we have thought about right now, yeah, the tool is run locally, but if it was maybe ran in an environment that could be shared among multiple analysts, there could maybe be a way to tag that Sarah's working on this report, Jackie's working on this other one, so that the same analyst isn't doing the same report twice. So again, it's on the to-do list one day.
the team's small enough for now. So.
Yeah.
While you were building this out, were there any sources that you thought were going to be good, like valuable data sources that your models ended up not picking up on? Can you talk about?
Like, what do you mean?
Like, let's say there's a vendor you think is really good, they've got good like brand recognition, but then when you actually start looking through the reports, they don't do a lot of identification of techniques. So maybe you can talk about
Well, a lot of the data that we're using is already in the attack site. So if it's made it to that far, then it's usually a pretty good source already to work with.
Yeah.
But I don't know if you have anything.
No,
to
I
add.
mean, I'll say, yeah. Actually, as I was putting the demo together, I was like, oh, I want to find a report that has a lot of techniques, right, to show everybody. And so I was like, oh, I'll go to some common vendor sites that I thought would have good reports. And yeah, whether it was our model or their reporting, like only a couple showed up. So I would say that that's not necessarily a bad thing, though, just depending on the type of report. So maybe I was selecting a report that wasn't talking about software or something in a way that would make sense for attack, but I ran into that, making the demo video. Go here and then there.
You guys had to go back to the data that you have, not sufficient context or wasn't described the way.
Yeah, so if we were looking individually at like some techniques that may have done kind of a bad job, I think one of them was like security software discovery. That was a really hard technique because a lot of in reports they talk about different antivirus like tools or whatever, which is what that technique sounds like from the example. So it can easily be kind of like, it can get thrown off pretty easily. So for those, we kind of had to look back and make sure like the data we were feeding to the models was correct and in the right format and didn't have any extra like characters or text that was kind of like throwing it off or outliers and things like that.
Yep. Question?
Piggyback on the question that was asked earlier, when you talk about the relationship that you guys have with the vendors, how do you guys actually prioritize those reports? You mentioned earlier higher ones, the medium ones as well.
It's kind of just based on sort of what we know is like a big group right now or a big malware, like or a big campaign that's happening, things like that. It's not really like a certain methodology.
Yeah, it's not a formal.
Yeah, we're like, oh, this
decision.
one's a new one on APT 41. It's a huge report. Like, let's prioritize our efforts on that over something smaller. So.
The attack framework is a community backed effort in a lot of ways. That there are going to be plans for being able to take individual user TRAMs, the data that they generated, the trained model, and then ingesting that back in, submitting it back to the overall project.
That's one of our hopes with this project. Yeah, absolutely. We hope that once it's open source and like especially those tables at the bottom where it pulls out the technique and the sentence it came from, that would be a great way to say, hey, attack, I did a report that's not there yet. Like, here's the table, here's the original source. Like, can you add that data in?
And we have people from the community that regularly reach out to us with reports that they find and they map themselves. So this would just make it easier for them to be able to share that with us too. So.
Is there any system to like opt in and automatically stream data back?
Right, not at this time. The idea we have had before, but just with the current workflow for attack, I don't know that that's going to be a great option. But I think one in the back.
So related to that question, are there certain organizations that they do assist for training models that are really sharing reports to the organization? Is there going to be a way for them to still sort of assist with that effort of training the models?
Not at this time, because the models is based on the database, which includes all the data from the reports. But we do recognize, since it will be open source, if it made sense, right, for you to keep the tool internal for your own use case, then we hope that there's a benefit there as well.
Yeah, so you could use it for your closed source reporting, but if that reporting is obviously not unclassified, then we wouldn't be having access to it anyways. So.
Yeah.
Yeah.
All right. Oh, one more.
You have the slide, but if you show that slide where you overlay like 80, 28, 29, I'm not a mathematician, but probably can use some kind of formula from that match up different groups.
Yeah.
Yeah.
No, definitely. Thank you. All right. Well, with that, thank you all. Feel free. Feel free to get a sticker or
Ask us questions.
ask additional questions. But thank you for your time.
Thanks. Oh my god, it took so fast, sorry.
Oh, I did too, so that's all.
We actually have 10 minutes to spare. No, you did a good job.
People had questions.